noch wach. Es tut mir leid, aber diesen Vortrag werde ich auf Englisch sprechen, weil meine technische Deutsch ist nicht so gut. So, sorry. So this presentation is going to give you hopefully some ideas about some more of the more complicated things in lighting control. We're going to look at 4 areas. We're going to look at fast pulsing. Then that will lead into how we need to synchronize all our pulsing with the camera, maybe a reject mechanism, and actually triggering the lighting. And that will lead into quite nicely into how we can use those in solving some line scan issues. And then for something completely different, we'll look at low current applications. So firstly, fast pulsing. It won't do any harm just to reacquaint ourselves with a typical diagram of a pulse, a light pulse, because that just helps us to understand some of the issues that we can quite easily forget. So here's a typical situation where we're using 2 lighting schemes. We've got a continuous illumination and we've got an overdriven LED. Because LEDs they're effectively current-driven devices, you can actually get a lot more current, a lot more light power out of them if you're using them within a certain pulse width. So you can see here in this example, we've got a continuous illumination and we've just set it at a nominal 100%. But if we were going to use it to its truest potential, we could say, okay, well, let's use a short pulse, but really increase the brightness. And here in this example, we've increased the brightness by 5 times. I imagine a lot of you already know that sort of thing. But now we start to get into things which become more important the faster we want to pulse the light. So what becomes important here is the actual rise time and the fall time. So when I say rise time, I'm meaning what's happening here on this edge here, and likewise on the far edge. If you're using a very fast camera shutter, you've got to make sure that your illumination is fully on during the time of your camera exposure. If the rising edge, when you give the trigger to your LED, from that point on to when you're onto full illumination, that's what I'm calling the rise time. Now, if that edge is quite slow, you might actually be moving into your camera exposure time. So you could end up almost like a truncated type of illumination. So you have actually got quite limited illumination during your camera exposure. So that could have some consequences. You could end up with a bad image, which could result in a blurred image because you're not freezing your motion. If you're in a line scan situation, you may start to get crosstalk from one line to the next line, particularly if you are using different lighting schemes. And I'll go into that more when we look at the line scan. So we started to get quite a few requests actually from the marketplace about making controllers faster. And a particular application that we worked on was using multiple lights for inspecting a mobile phone front and back using a line scan. And they needed, and also there's an added complexity that you had a long cable. There's something that I didn't mention as well, that the faster you want to drive your light, the things that fight against you are how much current you need to pump along the cable and how far away you are from the light. Now, there are some lights in the marketplace which have onboard control, and if it's the right light for your application, then you may have already solved your problem straight away. But if you have to use a light that doesn't have onboard control, then you may need to use an external controller. And you then need to seriously consider how far away will your controller be from the light. The further away, the worse it gets. And the optimum is you're right next to the light. Okay? And the other issue is how much current do you need to drive to the light? Unfortunately, the way particularly Linescan is going now, it's going faster and faster. Because it's going faster and faster, the shutter speeds or the exposure times are much shorter. Therefore, you need to get much more illumination into the camera. And all these things are fighting against getting a fast rise time. So we did quite a lot of research looking at different techniques into how we could achieve this fast rise time with a fast pulse. And typically when I'm talking fast pulsing, I'm talking pulsing in excess of 50 kilohertz, and quite typically in the area of 100 kilohertz. And I know there are Linescan cameras out there which are, it's quite common now to have Linescan cameras of the order of 300 kilohertz. But it very much depends on what your application is. So we looked at a number of techniques. I can't go into the actual technology of how we solved the problem because that's our little secret. But we did look at a number of techniques of how to basically overcome the physics, because you're fighting against physics. The requirements that we were getting was that people wanted to be able to have resolution of 14 nanoseconds. So they wanted to be able to adjust their pulse width in the order of 14 nanoseconds. And typically, if you've got ideal conditions, there's no reason why you couldn't have a pulse width of 1 microsecond. In ideal conditions. And again, that all depends on how far away you are from the light and how much current you want to use. So we did develop a new generation of controller, which combined some previous technology. And the message there is that it was basically a very simple system that was very much more plug and play, and took on board things like how to control the heating. Because one of the issues you need to think about is if you're going to drive high current over a long period of time, you need to think about the thermal issues. So you might need to think about having good heat sinking on your controller, whatever type of controller you end up using. You may even need to use water cooling. But different controller companies can work with you to help you solve that problem. And we were very pleased ultimately when we came up with a solution, because we got a really nice square edge. So we're typically getting rise times of the order of 200 to 300 nanoseconds, and likewise the off time. So we're almost getting like quite a vertical edge. So it means that by the time we're into the camera exposure, we have full illumination during the full exposure time of the camera. So we're maximizing the illumination. And we have already started looking at new technology to make things go even faster. So watch this space. Maybe by the time we have the next STEMMA forum, we might be able to do a little demonstration of exceptionally fast pulsing. So now we have all this lovely fast pulsing. Everything's looking good. The next issues that we start to face are, how do we synchronize everything? How do we make sure that my the signal coming maybe from an encoder. How do I make sure that synchronizes with the camera trigger? How does that trigger with the lighting? How does that trigger with the reject mechanism? So we have more complexities coming in. And maybe you don't have the luxury of using a frame grabber anymore, and you have to try and come up with some other technique of solving the problem. So some lighting controllers have the ability to do the synchronization work for you. So typically you could have an encoder input coming into your lighting controller. You could have a part present trigger, and then the controller will then make sure that you exactly synchronize your exposure of the camera with the lighting pulse to make sure that the actual illumination happens precisely within your camera exposure. You know, you only have to have your lighting pulse a little bit off, going a little bit outside of your camera exposure, and instantly you're losing a lot of your illumination. You'll have a false reject, and the system will start to fail. The nice thing about having off-the-shelf timing controllers is you don't need to be a PLC expert. You can just use the proprietary software in the timing controller to help you synchronize all your system. This was quite a nice example from a customer called Kitov, based in Israel. If you go onto their website, KITOV, there's a really nice bit of video footage at the beginning, which actually demonstrates the whole idea of the synchronization. So here they've developed an inspection solution around a robot, and they're using a timing control to synchronize the robotic movement. They also have their product on a turntable, and it's synchronizing the illumination with the robot motion and the camera grabbing and the light pulsing. And it makes for a very nice, tight solution. So we've got fast pulsing, we know how to do synchronization, and now maybe one of the things that we're starting to look at is line scan applications. And what we're seeing more and more is that people want to use multiple illumination with one line scan camera. So previously, you may have had one camera, one light. But now it's quite feasible to have one camera with multiple lights. And with the technology of fast pulsing and synchronization, you can make sure that you're pulsing your lights exactly with the frame rate of your line scan camera. So when your light is on, it's on precisely for the time that you need to expose that line. And when it's off, it really is off, and the next light's coming on. So there's no crosstalk. You're getting very clear, distinct illumination between the lines. And then in software, you simply extract the two lighting schemes, and you have two images for the price of one setup. Now you can take this much further, as some people do. So you have multiple lights with one setup. And within that, you can be controlling, you don't have to just control the on-off time, you can be controlling the pulse width, the intensity, so you can have multiple schemes going on. So with one setup, you could be inspecting the print quality, you could be looking at barcodes, you could be looking at surface defects, all in one setup. So if you're a machine builder and you're trying to maybe overcome a space constraint and you don't want to have so many vision systems in one space, then maybe a way to think about that is to look at having one line scan camera or saying that you could use an area scan camera if the solution works for it with multiple lighting schemes. So these are now very much in the realms of the doable. You've probably, maybe you or your customers have, if you're in a 24/7 operation, every now and again you might come up with a false reject because for some reason there's been a little bit of noise in the system, or somehow a second trigger appears. Maybe a mechanical relay didn't quite disconnect and it's remained closed, and so you get an extra trigger. Could be very embarrassing if a false product goes out of the production system because you didn't catch it. But there are ways by using your timing controller, going back to the timing controller, you can make sure that you're just using the pulses that you want. So you're rejecting all the noise out of the system. This is a specific example of where people are trying to solve problems with Linescan, particularly if you have developed your own illumination. And the important thing, if you're doing a web inspection, is to have very even illumination across the web. You could use software to try and normalize your lighting, but you lose the actual benefit of the light. Far better to actually control the light. So it is possible to address the individual segments in your illumination for your web inspection to make sure that each segment is behaving how you want it. So now we're going into something completely different. This is where we're looking at very low current operation. So maybe the scenario might be you're wanting to drive some LEDs in an automotive application. So you only need very, very low current to switch on your LED. So we could be in the realms of very much less than a milliamp. Now, you could solve the problem by just putting physical filters over your LED, but that could then affect the way you're reading that LED, and you're not getting very accurate information. The best way is to actually drive the LED with very low current. What we found when we were doing our research was that, and it all seems very obvious, if you've got a full-scale current range, and you're actually only wanting to look for 1% in difference, it's more than likely that you'll just lose that in the noise. So you really do need to use a controller that has a very low range. So typically, you want to be using a resolution of probably at least 3 times of what your accuracy is. So we developed a product which enables you to have a very low resolution, so it gives a very stable lighting output. So typically in this situation we had a 3 microamp resolution, so that we were very comfortable by getting a 10 microamp accuracy, and we got a very stable light output. So that sort of concludes and hopefully gives you some ideas of things that you need to think about or could help you when you're trying to solve some unusual problems. If you need to do fast pulsing, there is technology out there that can help you achieve that, but you need to remember some of the gotchas. You might think, oh yes, fast pulsing, I know that works. But then you think, but my controller needs to be 5 meters away from my light. or you need to drive very high currents. So you need to just think of the whole solution. There isn't always one easy answer. And then when you're using your Linescan application, you do need to think about making sure that you're not getting any crosstalk in your illumination. And again, you need to go back to thinking about the fast pulsing. And the thing about lighting control is there is no one simple answer. There are many little factors that can cause a problem. And Sophie will agree, you know, the customer will look at the data sheet of a product and think, solution. They switch it all on and it doesn't work because there's maybe one tiny parameter that's been missed out. So always look beyond the data sheet, always look beyond the war of the specification. There's much more to it than the numbers. And I'd always recommend actually trying out the hardware. Work with a company who will loan you some equipment, so you can always try it first before you buy it. Always try it out first. I always recommend that. Yeah.
How many samples do I need for our demo stock?
Well, no. If you have a serious application. Sorry, this is sales hack coming on now. If you have a serious application and you're just not sure, we'd be happy to work with Sophie to loan you a controller for you to try it out. That's a promise to you. It's not a problem. I can do that. We're based in the UK. We have offices throughout the world. In Europe, we predominantly deal through Stemma. Sophie is our contact person. We can offer direct technical support. So if you have a problem, you're trying to solve a problem, we can offer you direct technical support. So yeah, if you have a project that you need to talk to us about, then please do. We're downstairs. Always happy to talk about a project. Always happy to loan you equipment.
Thank you, Martin. But we